Hey everyone, welcome back. In today's video, I'm going to walk you through how to optimize your game characters for better performance using both Blender and Unreal Engine. We'll start by converting your character into a modular setup, making it easier to manage, customize, and optimize across different game scenarios. You will learn how to create LODs for each modular part, all while keeping ARKit shape keys or any other shape keys fully functional. I will show you two workflows. First, Unreal's fast and highly efficient LOD generation, which we will use as a primary method. Then Blender's clean and precise but more time-consuming LOD creation process. We will also go over cloud physics LODs, material optimization techniques to boost performance. So with that said, let's dive right in and start optimizing. Things we need to do in Blender. Clean up the skeleton, remove any unneeded bones. Remove vertex group with zero weight from different parts. Remove any unneeded shape keys. Remove all deformation groups if you still have any, in case you don't want an actual weight-based rig on your face. First of all, let's see what I have, so you can translate the logic to your character. It's important for you to organize everything before we start this, so you can avoid any confusion later on. So here I already have the folders set up nicely organized, and I have a character rigged, weight painted with 5 tiles of UDIM texture, with haircut meshes for eyebrows, eyelashes, face accessories like piercings and the inside of the mouse, and 2 sets of eyes for Blender and 1 for Unreal. And I have multiple hairstyles on which one of them, the original, is attached to the character's rig, meaning the hair rig is a part of the character's skeleton as well, which I will now going to remove and going to make it a whole separate thing. So I can change between multiple hairstyles in the game. So let's just start here. I will select the skeleton, go into edit mode, select the hair bones, then I'm going to press P to separate it. Name it root bangs medium, select the hair, go to the object, clear parents, then go to object, delete the modifier, then select the hair, then the rig, and with Ctrl P, let's parent it with the armature deform, since I already have the weight paint on it. Although for all the hairstyles to work perfectly, you need to have a common ground, something that match in every hairstyle, which should be a root bone. Look at the ponytail version of mine. As you can see there is a bone right here, which acts as an attachment point to the head, and this bone's origin, aka root, should match in every hair rig you have. If I go into pose mode, you can see that I have a bone constraint on it, a child of constraint, which targets the head in the character's bone hierarchy. If I hide this, you can see that the hair is on the ground, and this bone's origin, which will be the root in Unreal, is exactly at the middle of the world grid. This is how you should export basically every asset from Blender. You want to have your origin at the world grid center. This way your pivot point will be always perfect. The child of constraint here for me acts as a socket in Unreal Engine, although you have to set up the socket manually in Unreal. This just for demonstration and to keep both Blender scene and the Unreal close to each other as I can. Let's unhide this, get into my other skeleton and activate snapping. Then snap this to this and extrude it and let it snap to the other bone. Name this new bone something that represents this is the root. As I said, it has to be identical, so let's go to armature and switch direction, so it's exactly the same. Select the other bone and make the root its parent. Now we will need to set up the origin for this rig to be here and place it to the world origin. But I'm not going to do that just yet, and I will get back to it why soon. Until that, I'm going to place this in a hair folders so they are nice and tidy. But let's jump on the character and duplicate it. I want to keep my original character as one single mesh with my UDIMs and slice up this new one. There is a really good reason on why I need that in one mesh, other than keeping the flow semi-non-destructive. You will get it soon. Now name it, organize it. Now let's see the bones again. So here in the bone layer, you can see I have a bunch of other bones on my skeleton, which I don't need, and the game engines don't need it either. They are just extra calculations for the engine, so mechanical bones, control bones, and so on. Now, depending on what you want to do, you might want to keep some of them. It's really up to you. Usually the eyes and the jaw and a few more additional bones can be easily left out from the purging process, but you will have to reparent them, correct, and rename them, and so on. Now I have an ARKit shape keys and I'm perfectly fine with it, so I will delete all the bones from the face area. If you want to do a rig/weight based control rig in Unreal, then obviously you have to rearrange this optimally and leave just the deformation bones. Organize the layers is just for clarity. You can have up to 100 layers here. It won't affect anything in Unreal or any game engine as far as I know. Okay, so skeleton is basically done. Let's make the character modular first. Open a UV window. If we are going to edit mode and select all, we can see that it is tied up to 5 pieces as I mentioned. So head, upper body, lower body, hands and feet. We want to rearrange that UV, but under data, keep an eye on the UV map here. You want to modify this, or you can create another UV that can be called in Unreal or Blender as well with this node here if you are interested. But I don't need double UV here, so I will modify this current one. So to rearrange the UV tiles, select the second Udin part with L and press G, X, -1. So it will jump exactly one tile left. Now the next one, same thing, but this time X -2. Next, X -3 and 4. And they are all aligned in the first tile. So now let's add the materials, create the texture setup, and assign them accordingly. Now we can separate the body parts and remove the unneeded materials and organize it with new folders. Next, open up your folders, and for each mesh, first delete all the attributes you don't need. Before we move forward, we need to make sure that for the face parts like the eyebrows, eyelashes, piercings, tear ducts, eyes, and the inside of the mouth, weight painted to the head with a power of 1. Because without a weight-based face rig, the only vertex group that we will need is the head in these meshes. The only exception if you have a beard, which depending on the look of the beard should use neck vertex groups as well. So the easiest solution is to get rid of the vertex group. In this particular case is to lock the head group, then here delete all unlocked vertex groups. Now do the same on the earlier mentioned parts: eyebrows, eyelashes, face accessories, mouth, tear ducts, and the eyes. Now we need to delete all depth groups from the character parts since we no longer need them, since I don't have a face rig. To get rid of that, you can do it manually if you type here def and just press minus like crazy for each. Or you can do a shortcut and use this script to remove def groups automatically from the mesh. Open up scripting, paste the script. I will provide the download link in the description for all the scripts I will use. Once you paste it, name the script like remove def groups. Once you select the mesh and hit run, it will automatically delete all def groups for you. Do this on all of your parts. Next, we need to delete the vertex group that doesn't have any weight on them. For that, again, I'm going to use a really handy script, which surprisingly will delete all the groups that has 0 weight on the selected mesh. There is also an additional function in the script. If you, for example, want to keep a group that has 0 weight, but for some reason you want to keep it, you can use the lock function here. If you lock it, it will not remove this group no matter what. Go through all of them. Now once you have it, look for a vertex group that doesn't fit the code. So like this faceit main, which has weight of 1, but we don't need it anymore, so we can delete these kind of leftovers. But with this 2 script, we basically purged about 99% of the unused vertex groups. If you accidentally deleted something you didn't want, you can recreate the group by naming exactly the same as the bone. However, you will lose your weight painted data, so just in case, keep an eye on it. We are doing this because we don't want to carry over any extra unnecessary data to Unreal. Obviously, you don't have to have a modular character for this whole process. You can do this all together as well, whatever fits for you, but this will need some modification probably heavily because for LOD generation, we will use Unreal, and just like Blender Decimate, it will focus on decimating the parts where the mesh is dense, so it will always try to get rid of the face mainly and the fingers, unless we prioritize bones or vertex group. Organize the parts and get ready for LODs. Head LOD should contain the eyes, tear ducts, mouth, and the head mesh itself. This should be get decimated together. That means that it will be exported together to form one single mesh, since Unreal automatically combines them if we don't decide otherwise. Because of that, I can keep them separated here just in case. Now, since I'm doing modular, the best approach is to create a separate rig for the head itself, since usually the head will need its own animation blueprint and some unique own logic, so it's better to keep them separated from the rest of the body. For that, I'm going to duplicate my rig and call it root head M. I hide my main rig, and on the new rig, I enter edit mode and I delete every bone that is not necessary. So the arms and the legs, but keep the rig from the pelvis all the way up to the head. Even though the pelvis doesn't have any weight and a few bones here, I need this to properly able to attach this to the rest of the body in Unreal. And the exception proves the rule, since in this particular case, I don't want to move the origin at all, and I will export the rig just like that with the head mesh after I reparent it to this new armature. This way I'm ensuring that the head will match with the torso and the rest of the body 100%. I'm just going to clear the parent, keep transform, remove the modifier, then reparent it with the armature deform. And now if I check, it will move with it nicely. Now, if you want to keep everything easy, you can add a copy transform for each bone in the new head rig and select the corresponding bone from the rig. So you will only have to manage one rig, but this is obviously solely for Blender consistency. It's not necessary at all. Okay, let's check if everything is alright in the material preview. And oh, there's some hard-ass seams there. My acting skills are top-notch, I know. So the reason that this is happening is that because we cut the character to pieces, their vertex normals at the seams has been shifted slightly, which causing these hard seams. Let me show you. So I'm going to select both of the head and the upper body just to show you and go to edit mode and activate this. Display vertex normals. It will show you which directions are the normals facing. As you can see right here, they are a bit off from each other. However, they should point to one single direction. If you remember, I mentioned that there is a really good reason why I kept the original mesh besides the cutted one. If I go into edit mode and with all three parts selected, you will notice that the vertex normals of the original mesh are pointing in a different direction compared to the face and the upper body normals. To fix that, we will have to use a modifier called data transfer on all of the cutted parts. So let's first add one to the head. Select the source, the UDIM character, which is the single mesh character. Select face corner data, custom normals, and nearest corner and best matching normal. Now let's add the same modifier to the upper body. Let's look at it in material preview. Now that's much better. So let's add them one by one to the others as well. Or just select the feet, the hands and the legs, then last the head, then press F3, search for copy modifiers. Now it's all copied to the others with the same settings. Now we can't bring this modifier to Unreal, so we will need to apply it here. Before that, make sure you save your project. So let's apply them. Now we can also remove any unnecessary shape keys from our modular parts. For example, ARKit shape keys can be deleted from the body since we only need them on the head. If you have a specific deformation helper shape keys, make sure to keep them logically assigned to the mesh they belong to. Okay, it's done here, but when we are importing it to Unreal, we will have to modify the import settings regarding the normals. I will show you what in a few seconds. Export everything we did so far. So the hands with the rig, the upper body with the rig, lower body with the rig, feet with the rig. Select both brows with the rig, same with eyelashes, piercings, and the mesh with the new head rig, tear ducts, eyes, and mouth. A side note, it's really important that the name of the rig and the mesh name should not be the same, otherwise Unreal will go nuts, trust me. Now we are in Unreal, and when you import the cutted parts, untick everything up here and look for normals. And you need to untick recompute normals. This ensures that the engine will not recalculate the normals we just modified in Blender for the edges. If you skip this step, then the seams will be fully visible and it will act that we didn't do anything. Now quick jump, and I have everything organized, materials, textures, and meshes in folders nicely. Now let's assemble quickly the character in the third-person blueprint. For the mesh, let's select the lower body with the animation blueprint of the Queen Many or your own animation blueprint. Select the mesh, then add the skeletal mesh. Choose your upper body. The lower body should be the parent of this. Select the upper body, then add two more skeletal meshes to it. Select the mesh, which is the lower body, then add the skeletal mesh to it. This skeletal mesh should be the hands, and this one should be the head. And this one should be the feet. Now assign the skeletal meshes as well. Now select the head and add 3 child skeletal meshes for the face piercings, eyebrows, eyelashes. Go into the construction script, then get a set leader pose component. The new leader should be the mesh, which is the lower body. Get the feet, hands, and the upper body and plug them into the target. Copy this set leader pose component, get the head, and plug it into the new leader. And for the target, we need the eyebrows, eyelashes, and piercings. Now join them. Then when you hit compile, this is what you should see. So the head just floating and doesn't do anything. The rest of the body should follow the animation perfectly. Now find your head mesh to create an animation blueprint for it. In the anim graph, get a copy pose from mesh. Tick all these in so they receive every curve that the lower body have, then plug it into the output pose. Compile and save it. Now in the third person, select this animation blueprint we just created for the head. Compile it, and now the head should follow it properly. Since I already have a wrinkle system for the head, I need to import an animation for my newly created head rig to register all the curves. Since I duplicated the rig, I still have the animation data. If you want to know more about the wrinkle system setup, you can check out my previous video. So once I imported, I just quickly going to demonstrate how the modularity can work shortly. So back in the head blueprint, I add the layer blend per bone, get my face ROM animation, set it to loop and connect them up like so. Then add the blend mode instead of simple bone. I want to use blend mask. For that, you need to go to the head mesh skeleton. If you click here, it will get you there. Up here, select blend profiles, add blend mask, name it, then pump up the head value to 1. Save it. In the head blueprint, now we can select this blend mask, compile it and save it. Compile and save the third person as well. And if I hit play, as you can see, it just works. Keep in mind that blend mask bugs from time to time and there is still no fix for it. If you somehow saw that the head is a little off, that means that the blend mask not working properly. Just deattach the node, attach it again, compile, save, and it should work again. I know, it's kind of weird. Side note, if anyone was following the wrinkle tutorial, I created a post-process blueprint for the head on where the neck bone drivers are placed. And there is also another post-process blueprint for the lower body for the advanced jiggle physics. Since the upper body is the child of the lower body, it will transfer it. Additional side note, if you have a modular character, at your skeleton you can use this create data asset, which contains your mesh parts, so you can see the skeleton properly and fully attached together. Also, it's a good idea to create a shared animation blueprint, which just simply copy pose from mesh, with all these 3 ticked in. Then apply it as a post-process blueprint for all the face parts. Now that's out of the way, let's create the LODs. Let's start with the head first. Open the skeletal mesh, and here at the asset details look for an LOD, and change this whatever LODs you want. I want a maximum of 4, so I'm going with that and apply the changes. Then it's going to take a few seconds. And now up here, if I'm going to change the LODs, we can see that it is successfully created it under a few seconds. Just way easier here than in Blender with decimate and triangulate, but it's far from perfect, so we need to tweak a few values. I will try to give you a quick guide on this. So with LOD 0 selected, the first thing you will notice under LOD settings is the LOD info section. The screen size value here determines when the engine will switch to a higher or a lower level of detail, based on how much of the screen the mesh occupies. You will need to tweak this value if you want the mesh to switch to LOD 1 later or sooner, but obviously if you change one, you will probably have to change the others as well to make it logical and consistent. As you can see, if I switch between them, it's getting smaller and smaller. I will show you how to visualize this change in the game soon. Next one just helps avoid flickering when changing. I never changed it before, it just works well as is. Now next one can be really useful, which is the bones to prioritize. It helps you create a better resolution. The best example is at the hands and the fingers. Once you've selected the bones you wish to target, you need to set the weight of prioritize to a high value like 5000. Then if you change something, you will always have to come down and hit regenerate. So it will regenerate the current LOD you modified. But also handy here is that the bones to remove. So for example, at LOD 1, you don't want a specific helper bone or a face rig part. Here you can remove them on that specific LOD. Termination is just determine how the reduction should happen and with what percentage. So for example, if LOD2 is a bit jagged, then you can increase this value a bit to get more detail back. But what really makes a big difference are these two values, remap morph targets and lock mesh edges. Remap morph targets is quite self-explanatory, and yes, it does remap your morph targets to lower LODs. You need this because it does not create your morph targets by itself. And in Blender, you also have to trick a little bit to get the shape keys back, because in Blender you can't apply modifiers with shape keys. Just in a very specific way that I will show you if you want to go that route, but this is just way better. Let's test this in action. So hit remap morph targets at LOD 1 and regenerate the mesh. Now if I use any shape keys, it just works great. Now lower LODs will be in a little bit of trouble, but I will talk about it in a minute. So the other important thing, as I mentioned, is a lock mesh edges. This is extremely helpful. This is especially useful when you have a modular character. What this does is that it prevents the UV cuts from collapsing. As you can see, currently the edges at the neck where it should connect to the upper body is fully random and all over the place. There is no way it will match the upper body if you leave it like this. So you will see holes all around the modular parts, which is not very pleasant. But if we check this to true on all of them and regenerate it, it will always going to ensure us that the seams will be in great shape. If you switch to wireframe here and in the previous scene hide the background and the floor and keep changing the LODs, you can see that there is a cost for this, some extra triangles that flows there, but I can leave it that so as the engine, it's way better alternative than leaving a huge gaping holes. So these are the main stuff that is really important. You can really modify this extremely detailed as your hard content. As you can see, there is a bunch of options for it, but it's perfectly fine like this as well. Now, I don't want to recreate this on every time, so for that, there is a great option, generate asset. This will generate an asset based on the settings we just set it up here. So let's create one and get inside of it. Now, logically, I don't want my last LOD to remap the morph targets, as this will be really far and distant. So it's pointless to have it on any of the mesh. So I'm going to untick that. Save this asset, and anytime you change this asset, you have to come into the meshes that has this exact asset and hit regenerate. It won't affect it automatically, unfortunately. Now let's apply this asset to all of the cutted parts. So set the number of LODs to 4. Select the asset, then hit apply changes. Now repeat the process on all of the cutted parts. Next, let's create the piercings on which I will not use this asset we created since we don't need to consider the edges this time. However, we need to remap the morph targets until LOD2. For LOD3, again, we don't need it. Instead, what different here is that I will change the last LOD to max vertices and set it to 0, which will leave me with minimal vertices, since I basically don't want anything to be visible from the piercings in that far distance, because it's just pointless calculation. Regenerate, and that's it for this one, so you can save it as a present if you have any other face accessories. Now let's jump to the eyebrows and eyelashes, which also uses the similar logic that we want the last LOD to be full nothing, basically. With a little bit of node play, you can turn off visibility as well for the meshes, such like this, to avoid rendering even these few vertices. But I'm going to go with that and save this as a present, like facial hair or something. Now let's save everything and let me show you in game. So if I hit play, press F8, then at lit, look for mesh LOD coloration. We can see if I zoom out, it actually creates the LODs. Now, as I said before, the screen percentage, you can change on what distance it will start. So if it's not good for you, feel free to tweak it. Just for demonstration, I recreated this simple actor blueprint. You can do that too. It's the same setup, just like in the third-person blueprint. If I place this actor in the scene and select all belonging parts here and look for LOD, force LOD, you can actually visualize how it's looking on 1, 2, 3 or 4. You can see that the mesh edges works perfectly, so no holes anywhere. I mean, who would not like that Tomb Raider box boobies? However, her head kinda reminds me of Mason Verger from Hannibal, and I think we should fix that. As well as LOD2 doesn't seem so right. Let's see if the animation and the morph target's working. So for that, hit simulate. Of course, if you have a face animation setup, just like I did. Seems they are working as they should, and on the last one, it's turned off. Now about the fix. First of all, I will remove this data set from the head and I will make this unique, like increase the percentage of triangles on the last load. Maybe even match the LOD2, then regenerate it. Then we are going to fix that inside Blender. So to do that and recreate this LOD system in Blender as well, we can actually export all of these LODs. For that, right click on the head mesh, asset action, export, and here make sure export morph targets checked. And I always say untick level of detail. Well, now it is the time we need it. So let's tick in level of detail and export all of them. Now in Blender, you can see we have all of the LOD meshes. And what we want is to fix mainly the last LOD, especially in the head. We don't want to touch the neck part, but we want to remove edges, basically manually decimating it. We're keeping the mesh itself relatively close to the original. So we don't get that horroristic look. Even though it's far from the camera, it should just look fine. Now in the exported asset, even at LOD3, you will see the shape keys because we ticked in export morph targets. However, as we set it up in Unreal, it's going to behave accordingly here as well. So LOD3 shape keys will not do anything. However, the LOD2 will have working shape keys, which we can modify and tweak. In the end, I will show you another cool trick if you want to use your LODs in Blender with the facey trick. Since you have the working shape keys, you only need the drivers, and you can easily copy the drivers from one mesh to the other. But now let's quickly fix the head. So there is a couple of ways to do that. I mentioned earlier that the decimate will focus on high dense parts, unless we prioritize a bone or a vertex group at large parts. Now here in Blender we can do exactly the same thing as in Unreal, like prioritize bone, but here we can prioritize currently selected vertex group. Instead of using decimate modifier, in edit mode there is an option for it under cleanup and decimate geometry. Now this is better because we can do the same thing, but we can apply this and it won't require us to delete the shape keys. We can tweak the ratio just like at the normal modifier, but it's decimating the whole mesh. To prioritize, we need to check in vertex group, but before that, make sure you have the vertex group selected that should guide the decimate. You can create a custom one or just one major part like the head. Give this a high value just like in Unreal, like 200 or 500. Then tweak the ratio. I don't want to go too low, so I keep an eye on the statistics up here. Also, I don't want to affect all the meshes. For example, I don't want to affect the eyes or the tear ducts. So with L, I'm going to select just the head and use the decimate around 0.7. Yeah, 0.7 will do it. And in the other part, I will remove some additional triangles, like in the mouse area, the back of the eye. I'm also going to reduce the triangles on my tear ducts as well. Now that seems it's done. I'm also going to fix some more targets on LOD 2. We're going into the shape key and manually modifying the vertices. Okay, so this is the way to fix the Unreal LODs quickly. Now it's all done. I can show you how to make the LODs work with the Faceit control rig as well, but this method stretches into the Blender LOD setup, what I would call a more professional and clean LOD generation method. But as I said, it's more complex and time consuming compared to just hit one button basically. So what I showed you is one way to preserve shape keys here in Blender, but there is another great tool, which will be an add-on called Mesh Data Transfer from Blender. So what this awesome add-on can do is that it can copy shape keys and copy rig-based driver functions to another mesh with different geometry, which is perfect for us for LOD generation, since the decimate and triangulate obviously going to distort the number of vertices and their location. Without this add-on, we wouldn't be able to copy the shape keys. So the Blender process would start out with a duplication, delete all shape keys on the new mesh, add a decimate modifier, make sure it's the first modifier, select planar and UV, 5% will be good now, apply it, add a triangulate, make it first, beauty on both, and keep normals, then apply. Find the add-on under Data tab, select the shape keys, you don't need snapping, and for source select the original head mesh. Just hit transfer mesh data, and now we have the shape keys, and here down below there will be rigging helpers. For source, select your control rig, which in my case the Faceit control rig. You don't need to select anything else, and just hit transfer shape key drivers. And now it's all working perfectly. Now this was the Blender method. And this is how you can make your LODs to use a Faceit control rig as well. Now to export certain LODs, we don't need the rig that come with the mesh. We want to export it with our own rig, from which we initially imported to Unreal. So let's create a parent, keep transform, remove the modifier and parent it to the original rig. Select the original rig and the LOD mesh you want to export, then export it. In Unreal, just in case, import it to a folder we are selecting a matching skeleton. Now in the head mesh, go here and hit reimport LOD. And now this is our new LOD tree. Since the mesh contained blank materials when exported from Blender, it will going to show up here. To make it work, just reassign the correct materials at the LOD section, then delete the extra blank materials. The reason I imported it into a folder as well, because when you package a game, it should find a reference in your content somewhere, as far as I know. Now it's all looking cool, but we should do something about the materials and optimize them as well. So let's do something about it. So the original material of mine is now renamed to Face from the last episode, and the material instance is now Face LOD 0, and that will make sense soon. So as I said, don't really use virtual textures here, use normal textures instead. Let's start modifying it. So the first thing is to change the texture samples to parameters so we can change it dynamically. Right click, convert to parameter, name them logically, color main, color wrinkle mask 1, wrinkle mask 2 and 3. Before we jump into the others, we start organizing this to groups to be more pretty and tidy. So here are the groups. If you don't have any and you want to create one, just click inside and type in whatever you want to see in the material instance. In my case, this will be base color. Let's jump to the normals. Let's convert them to parameter and name them. And give them a group named normals. We can convert the occlusion roughness metallic to a parameter and give it a group roughness. You can even create parameter out of this array sample here in the function and put it into a group called mask if you plan to use this material on multiple characters. Now back in the material, we want to add some sort of a switch mechanism, so we can switch off certain parts of the material at specific LODs. For that, we are going to use a static switch parameter. I will call this animated diffuse and give it a group LODs. And set the default value to true. For the true input, I want to add the original output of my animated wrinkle maps. And for the false, I want to add the simple main color of the character and plug it into the base color. I'll do the same on the normals as well, just before the height map or the detail normal if you have one. Call it animated normal, value again true. And now I want to add another switch parameter and call it detail normals. Now this detailed true is the result of the blend angle corrected normals, and the false should come straight from the animated normals. You can convert the height map strength to a parameter and put it into a group of normals. Also, you can create a group for your subsurface as well. And now if we save it down, in the material instance, we will have these nice groups here on where we can dynamically turn on and off functions or change textures. So for example, we can switch off the wrinkle diffuse, the wrinkle normals, or detail normals. In later tutorials, this will receive some more things, but it's perfectly fine for now. However, we don't want to change anything here because this is for LOD 0. We want a child material basically of this. I will create two more. So right click, create material instance, name it LOD2. And from LOD2, I create a material instance called LOD3. The reason I didn't create LOD1 because I don't really want to change anything when the character face goes from LOD0 to LOD1. That's why I'm going to skip that. So how to apply these on the mesh to change dynamically when LODs trigger? It's pretty simple. In the head skeletal mesh, add two more materials here. Then if you switch to LOD2 under here at LOD section, you can switch different material slots. Assign the new LOD materials to the element 5 and 6. Then just pick the new material. Same for LOD3. Now save it and let's modify these two instances, for example at LOD2. I don't want animated diffuse to be on since it just enchants the look. I also don't want detail normal as well, but I will keep the normals. For LOD3, I don't want anything, not even the normals. But let's make this more interesting, like with a texture switch. So even from the lower LODs, the eyebrows will be visible. But instead of cards, it will be using a texture. For that, let's hop quickly back to Blender. So I want to paint the eyebrows on the texture. Last time I showed you a texture layer painting method. I'm going to use the same method to paint on the face diffuse, but instead of manually painting eyebrows, I will do a brush really quickly that exactly matches the eyebrows. For that, I will hide everything except the one eyebrow. Get the camera, change it to orthographic, change the resolution to 4K, for example. Render Eevee. In the view layer under passes, check in Z. In the shader editor, for the world, we can set a white background, and you don't need any light in the scene as well. Place the cards in the center of the frame. At the color management here, change it to display P3 and view transform to raw. Hit render image. At the compositing tab, check in use nodes. Get normalized from depth. This depth will be only visible if you checked in Z at the passes. From that, get an invert color, viewer as well. Plug the invert color output to both composite and viewer. And now we already have a perfect brush. You can save down this image now. This way you can also create custom haircuts as well. If you create curves, then convert them to mesh. But obviously I'm not getting into that, it's just a quick hint. Now back in our original scene, I set it up the layer for painting. Again, if you're not familiar with this method, you can check my previous video about the wrinkles. It's chopped to segments, so you can easily find it. So in the texture paint mode, select for example paint soft, add the texture, find the brush we just created, make it stencil, and hit image aspect. Let's change it to black. Once we have that, it's almost done, but if now we are going to paint on it, nothing will happen, it will just paint pure black. To fix that, under texture, at alpha, check in calculated. And now it's going to behave as it should. Just a reminder, you can delete it with erase alpha and then paint with mix. Obviously you can paint with your brush with any color, but her eyebrows are black, so I'm going with that. So in camera view, I just check and roughly paint under the eyebrows. To flip the brush, tick in flip axis, then just rotate it accordingly. Now if I hide the eyebrows, it's just looking good. Bake that new diffuse combination to a separate image, which I already have here. And now even at LOD2, I think I will use this, so I will switch the texture at the instance. And if you do that at LOD2 and save it, it should update it automatically in LOD3 as well. But just in case, check it, and if it didn't, just change it. And now in the viewport at simulate, if we check and force different LODs, it should work. Now one last part left, which is the hair. So if you remember, I said I don't want to align the original with the world origin. And that's because for LOD3, I will want basically just one simple mesh for the hair. Just like before, I will generate all LODs in Unreal, but I already prepared a mesh for the last LOD. So this mesh, it meta-humans called helmet. Since I used Unreal Hell, I was able to get that helmet mesh easily. But if you have your own mesh, the best way is to duplicate that mesh and use a modifier named remesh. And use a voxel size of 0.01 and check in smooth shading. And as you can see, it's almost identical of what I have here. And depending on the complexity you are looking for, set it up and then apply it. Then you can remesh it for a better flow, or just set up the UV with the current mesh flow. This mesh will only become visible in the far distance, so it doesn't have to be high detailed at all. This method is quite common, to use a different mesh completely for a different LOD. For example, in optimal case, I would have created a new mesh for the inside of the mouse, which would have been just a few planes that uses a texture variation to mimic that the teeth and the gum are two separated objects. But this tutorial is already extremely long, so I'm not going to do that now. Now just connect it with automatic weight, because it doesn't really important. Make the base bone weighted with 1. And now I set the cursor to the bone and set the origin to the cursor. Then get the cursor and place it to the world origin. Then selection to cursor. Now apply the transforms. Let's import both separately. So haircuts and the rig, then the helmet and the rig. Now in Unreal, I already have both of my hairstyles with their skeleton as well as the helmet mesh for the hair with the bangs. All of them has set it up materials, and just as I showed you in the hair dynamics video, I set it up the physics, so it has post-process blueprint with rigid body and an extra cloth physics as well. The only big difference is that for cloth physics, there is no physical asset used. It's totally empty. Instead, inside the third-person blueprint, I will use a little trick to resize the collision from the head. So in the third-person blueprint, add another skeletal mesh under the head, call it hair or hair asset, it doesn't matter. Now if I add any of the hair, they will appear in the same place, just as I told you so. But we need a socket. We don't want to attach this with the construction script. We want it to be its own thing that just follows a socket in the head skeletal mesh. Create a socket on the head bone and get a preview mesh. Any of your hair skeletal mesh will do it. Modify it. Okay, it's fitting now. If I remove the preview asset and if I add the other one, you can see it's perfectly matching. That's why we need that one matching bone in every hair asset, so it will always attach to the socket properly. So for a third-person blueprint, I want to add a collision for the hair cloth physics. To do that, just go to the hair and look for on component activated. And from that, get and add cloth collision source. In source physics assets, I select the head physics asset. For target, it's the hair, and for source component, it is the head. Just for reference, this is how the head physical asset is looking like. Now once that's done, compile and save everything and test it. And it's looking as it should. And as I said, now I can switch back and forth between the hair assets. So let's create these LODs for last step. Generate 4 LODs again. Yet again, this will be a bit unique regarding the setup, so I don't need the morph target remap, neither lock mesh edges. Instead, I will modify the percentage of the LODs. So I want a bit better quality. So for LOD1, I'm going to set a percentage to half to 0.5. For LOD2, 0.2. And for the third one, I'm going to re-import my helmet mesh. Again, change or create new materials or material instances that is less complex than the first one, and apply it to the last LOD. Now we are almost at the end. Just one more important thing, which is the LODs for the cloth physics. The way this works, that it is currently only available on LOD 0, which is the highest quality. But I want it to be active on LOD 1 for sure, and maybe even on LOD 2. For that, select your LOD, select your mesh, right click, and create cloth LOD from selection. Select the asset, and LOD settings and hit create. Now in the corner here you will be able to switch between LOD 0 and LOD 1. However, don't confuse yourself, this dropdown has no relation to this dropdown menu here. This dropdown menu allows you to modify the mask, aka the actual cloth paint. However, it's not allow you to change the chaos cloth config, just the paint. And the weird thing is that it is not copying or remapping your paint. However, I think it should. You have to go inside to your new cloth paint and manually paint this LOD1 again. But before that, make sure you apply the cloth to LOD1 mesh. So I was aware how I did it the first time, so I'm going to replicate it. Depending on how the end result will look, you might want to strengthen this time to avoid big differences at the LOD switches. So for example, as you can see, it's kind of not that loose here at the LOD1, so I will strengthen the lower part just a little bit. Now it seems good enough. Now let's test this in gameplay. And as I can see, everything working as it should. Character is optimized, the main problematic materials has been optimized. Seems it's a wrap for now. Hopefully you get the idea how to optimize your characters using both Blender and Unreal. If you found this helpful, don't forget to check out my other videos or spare me a like and or a subscribe. With that said, thanks for watching and see you guys in the next one.